I'm Chris Bailey. I'm part of the IBM and Strongloop team. When I'm not staring at my laptop pretending to work, I do monitoring and diagnostics development, so trying to make it easier to understand what your application's doing, and should it fail, trying to understand why. I'm available on Twitter and GitHub. I've seemingly made it deliberately difficult to find me. My Twitter handle's got 2 underscores. And I kind of learned from that because people could never find me. So when I created my GitHub ID, I thought, well, I'm Chris Bailey. C. Bailey had already gone, so I thought, well, I can do an interesting C. Bailey using C. Bailey, as in the water, the area around water, the other side of a tree from the wind. But obviously, if I say to people I'm C. Bailey on GitHub, you're never going to find me. So it's interesting. But I'm going to start today by starting off with a quote from Arthur C. Clarke. His third law is that any sufficiently advanced technology is indistinguishable from magic. And we saw in the keynotes yesterday that when you do an npm install, on average, it pulls in 70 modules. So that means that the average Node application now is already complicated. And this is going to become increasingly so when we start to build applications which are scaling to hundreds of thousands of users and being deployed over multiple machines. And whilst your application may look like magic, you really do still need to be able to look behind the curtain and see all of those dials and cogs that are whirling and the lights that are going on in order to be able to understand what's happening in case anything does go wrong, or if you want to be able to do intelligent things like scaling. So when you've got your Node application, there's a whole number of different users that actually want to be able to see and understand what's going on at runtime. So you've got developers. So your developer may want an IDE integrated view of what your application's doing whilst they're doing development. They want to understand how the code flow is being executed. They might want to be able to do some early performance engineering and so on. You've got your QA engineer. Your QA engineer wants to be able to do testing that actually matches what users do in production. So you need to be able to see what your users are doing in production and what the code paths are that we need to stress test most highly in testing. You've got operations. These guys need to be able to understand whether there are any errors on the system. You don't want the first understanding that you've got an error being someone raising an issue on GitHub, or you having a ticket being raised, or a phone call coming through from a customer. You've then got the application owner, so the person that's actually being responsible for the deployment of the application, who cares about availability, and they care about whether or not the application is scaling to incoming user workload. And again, as we saw in the keynotes yesterday, you also have the CIO or the CTO who's interested in more of the business side of things. How many users do we have on the system? How long are they staying for? What's our conversion rate? Do users actually come and buy, or do they just come and browse? And all of this you can get from monitoring information. But each of these people has something different that they're interested in, but it all comes from the same underlying data. They just need different perspectives on the same information. Then on the other side of it, you actually have machines or robots who want the data as well. So you've got load balancing. Right? You want to be able to balance load across your cluster of instances, and you probably want to be able to do that intelligently according to which machines can accept more additional load. Then you've got auto-scaling. So you may currently have 10 instances deployed, but once they reach the maximum capacity that they can handle, you need to add the 11th instance, and you need to be able to scale out to deal with more incoming load. At the other end of the scale, you might want to scale in when you're under low load and you want to free up machine resources. You also have health management. Do I have a machine that's got a resource leak and it's about to run out of memory? And before that happens, can I spin up another instance and take down the one that's leaking? And finally, not really a robot, although they sometimes feel like it, you're going to have financial controllers. If you're deploying into the cloud, every instance you deploy costs money. They're going to be interested in what the return on investment is on your application. Are you actually making money from users buying or paying to use your application against the cost of running it on the hardware? So a huge range of different people who want to have different perspectives on the data. And when you give the data from a production failure to a developer, they need to be able to see it's the same data that they're used to. So one set of data that's required in many, many different places. So the next challenge is what data is actually useful. So NPM causes us a problem. We saw yesterday that there is a huge growth in the number of NPM modules. There's currently something like 220,000 modules available, and it's growing at 304 a day. So that means that you can create all the monitoring you want in the world. I can create a monitoring product, I can try and give it to you, but the chances are the modules that I create data for do not match every module that you want. And it doesn't matter how hard I work, I can't accelerate it at 304 additional modules being instrumented every single day. And that's why open source monitoring really does make sense. You need consistent data, but lots of different users want to see that data in different ways. And the rate at which the Node ecosystem is moving means that any monitoring product is never going to be able to keep up with the acceleration of the capabilities of Node and the things that every individual user actually cares about. So anybody should be able to extend and add the monitoring that they need for whatever their application is. So that brings us to the project that I work on, which is Node Application Metrics. It's available on NPM and it's available on GitHub. It provides producer and consumer APIs, so you can add custom events into it. Everything comes out as an event callback. There's a probes framework and there's a drop-ins capability. The probes framework lets you probe NPM modules. The drop-ins capability means you don't need to raise a pull request against the project to add monitoring for a new component. You just create a probe and you put it into the drop-ins directory and it will run it for you. And it does resource, runtime metrics, it does tracing, it does request tracking. It's got support for a number of common modules. So HTTP, Socket IO, Redis, MQLite, MQTT, Postgres, MongoDB, and it's got connectors to a number of existing monitoring stacks. So there's a few that we find interesting. There's currently open source connector projects for Graphite and Kibana. Nagios, Immune are kind of interesting, but we haven't yet done anything with. So anybody that wants to contribute that would be gratefully received. So looking at those two, statsd. So does anybody here use statsd in Graphite? OK, so a small number of people, but that's good. So in order to use Node Application Metrics with statsd and Graphite with your application, you just take your application, you add a single line of code, which is to require the statsd module, call the statsd constructor, and that's it. It will collect all available information. It will send it via UDP to statsd, which is a node process that you run on your machine. That then forwards the data to Carbon and Whisper, which is a cache and data store on your machine. And then there's a number of visualization apps that you can use. One of the most common is Graphite, which is a Python Django framework-based dashboard. So with one line of code and some open source components that you install in your machines, you can get a visualization of the data that's coming out of your application. And one of the things that you get through the use of statsd, Carbon, and Graphite is a dashboard builder. So they kind of look at it and say, we don't know what you need to know. So we're going to allow you to drag and drop and create a dashboard that actually tells you what you need to know for who you are and what you want to see for the application. And the situation's almost exactly the same for Elasticsearch and Kibana. It's a single line require to your application. It does bulk updates to Elasticsearch. So every 30 seconds, it does a client.bulk to Elasticsearch, which is an Apache Lucene-based database. And that, again, has visualization through a browser application called Kibana, and Kibana is actually a Node application itself. So that, again, does much the same thing. It's a drag-and-drop-based dashboard builder, but it also has text analytics. So you can run analytic queries over some of the data. So you can look at things like your SQL queries. So one of the problems with doing correlation on SQL queries is you're possibly querying for a given user or a user ID, and that means you get a huge range of different queries, and it's very hard to do correlation. Because Lucene will do significant term analysis, it means you can actually group together queries which are similar but for different indexes or different users or different values. So now for the important bit, demos. Okay. So what I'm going to do is I've got an application called Acme Air. It's an open source benchmark for Node.js. And when I run Acme Air and open a browser, so it's just a simple application that uses Express. It uses MongoDB, and it's a mocked-up flight booking system. So you can log in with a given email address, you can check in, you can check for flights, and so on. Now, if I then wanted to add some monitoring to it, so I just add my metric stats.d require and run the constructor. And now I can start the application with monitoring built in. Now, a couple of other things I'll need to do is I need to start stats.d. Where are we? I will also need to start Graphite. Okay. Now, Graphite, the web app, runs on port 8080, and it gives me the ability to start creating charts. So it gives me a list of my stats on the left-hand side. I have gauges for CPUs, so I can add process and system CPU information. And I can start doing drag and drop building of information about my application. So we've got CPU, we've got event loop latency, we have garbage collection, we've got timers for GC and HTTP requests and MongoDB requests and so on. So it gives you a fairly rich set of capabilities to start drag and drop building charts and build a dashboard that talks about your application. So if I go back and then do the equivalent for Elasticsearch. Now, one of the challenges for an application is that for URLs on HTTP, you can have a number of dynamic URLs that are created. And one of the things that Acme Air does is when a user logs in, we actually use their user ID as part of the REST API. So that means you end up with potentially hundreds of thousands of different URLs that we could be collecting data for. So one of the things we've done in AppMetrics is give you the ability to rename or group together URLs. So what we've got on the screen here is a couple of filters. This lets you set a pattern, and it's just a simple regex. And it says, when I get a request on bookings by user, just take that and replace it with user ID rather than actually containing their ID itself. And I can do that for two patterns. One is for bookings, and the other one is for customer IDs. Now, you can also actually say I want to ignore certain URLs and not to do monitoring for them by setting the to value to just being open-close quotes. So if you leave it as empty, we effectively filter and ignore it. So if I start Elasticsearch, And I start Kibana. And I start my Elasticsearch instance. So one of the things you can see when you look at Elasticsearch is there's a whole set of mappings that have just been added when I started my application. So what we've done is when you start the Elasticsearch connector, we actually inject a whole load of description of the data that we're about to send to Elasticsearch. And it tells it how to format the data. So when we send it CPU data, we tell it that this is actually a percentage of total. When we send it memory information, we say it's not just a string of numbers. Those are actually bytes, so represent them as megabytes and gigabytes. And we actually inject a whole number of default charts. So when you open Kibana, which I'm just about to do, I can actually ask it to open a default dashboard that we upload out of the box. And it already has some information on CPU usage and garbage collection performance and physical memory usage. So if I then set that to auto-refresh every 10 seconds, and one of the other things that I can do is that the Acme Air benchmark, being a benchmark, comes with a load driver. So I can run the load driver. And this is going to start making a whole series of requests through Acme Air using JMeter as the benchmark driver. So that's a whole set of URLs being hit. And I can go back to Elasticsearch, and on our 30-second bulk update, we should start to get some data through that shows us the URLs being hit and the responsiveness for them. That is if I turn off the pause. So let's tell it to refresh. There we go. So this tells me that the query flights URL had my slowest max duration. It took 30 milliseconds to respond to it. So each of the bars is a different URL, and there's a maximum duration bar and an average duration bar, so I can see which of my URLs had the slowest responsiveness. But if I look at this and I find that there's additional data that I want to be able to represent, you have the option of going to visualize, and you can start to build charts. So I can say I'd like to have a line chart, and I would like that line chart to represent an average, and maybe what I care about is the average maximum event loop latency. So I can select that, and I can say that I want to have a timeline for it, and I can hit run. So that shows me that I had a spike that was a 13 millisecond latency on the event loop. So I've just built an additional chart. It only takes a few seconds to do that, and you can then elect to save it, go to the dashboard, and add my event loop chart in. And where's it gone to? There we go. Just being slow, and therefore it's given me several versions of it. But you basically got the ability to very rapidly build a dashboard. You can then save it. You can share it with other people. Because Kibana's a web app, you can host it on a central server, and it's backed by Elasticsearch, which gives you a distributed memory database. So you've got the option of hosting this centrally inside your data center. Every application comes in with its own process ID and application name, so you can identify one application versus another. And you've got a way of very, very quickly starting to generate and collect information about your application. including what URLs are being hit and how long they take to respond. You've got database tracking information, and you can overlay URLs with the database time to see whether it's the database time that's dominating the response to an HTTP response and so on. And with that, we're down to 27 seconds over. So any questions? Yep. So some tools to generate. So the load driver is JMeter. So it's Apache JMeter, which is a small Java application that does multi-threaded, multi-client load testing. Yep. Any other questions? OK, so Node Application Metrics is out there on NPM and GitHub. It's on its 4th version. We've only actually been going for about 5 months. Our last release went out yesterday, where we added support for another 6 or 7 modules, including Event Loop. And basically, we are continuing to expand that set as rapidly as possible. But because of the growth of the rate of modules on NPM, any input that people have on modules they're interested in or actually contributing is gratefully received. Thank you.